Okay, good morning, everyone. This is indeed a very big difference compared to what we had yesterday. Okay, yesterday's screen was so small and so difficult to see. Today's screen is so big. Okay, so this is a very good venue. All right, so as usual, let us recap, okay, on what we have learned on our previous lesson. So yesterday we talked about limiting reagent, short form LR, okay, and excess reagent, okay. So what do you remember about limiting reagent? Any points? Okay, determine the yield. Yes, okay, it's going to determine the product, how much of product is being formed. And then how do you calculate limiting reagent? The what? Okay, the leftovers, that will be excess. Okay, so here we have leftovers in the excess. Okay, limiting, there will be no leftovers. Okay, what else? How do you calculate limiting reagent? If you have the number of mole, how do you determine which reagent is limiting? Very good. Okay, so you have the number of mole, you divide it by your stoichiometry ratio. Okay, and the one with the lowest will be your limiting reagent. Okay, all right, so next, okay, theoretical yield, actual yield, and percentage yield. Okay, what do you know about theoretical yield? What does it mean? 100% perfect yield. Okay, what about actual yield? Okay, when you done experiment, okay, experimentally, okay, how much is the yield? So if I were to compare actual yield and also theoretical yield, which will be more? Very good. Theoretical will be more. Okay, and then percentage yield will be your actual divided by theoretical multiply 100. Okay, all right, and then we learned the last few, okay, were like revisions. Okay, so how do you form ionic compound? Okay, you have to know the charges, and from the charges you then cross multiply. Okay, where do you get the charges? What do you remember about charges? What is that? Where do you know the charges? Do you have to memorize each and every charge? Sodium is +1, chlorine is -1. From the periodic table. Okay, very good. Can you explain further? What about periodic table? Look from which part? Very good, the group. Okay, so what does the group represent? Valence electron. So from the valence electron, what do you determine? What is the configuration that you want to achieve? Okay, whether it is duplet, 2 electron, or it is octet, 8 electron. Okay, what else do we know? If it is metal, what will happen? Positive or negative charge? Positive. It is non-metal, negative. Okay, so these are the things. And then a balanced chemical equation. Balancing chemical equation means the number of atoms on the left, on the reaction side, must be the same as the number of atoms on the product side. Okay, so you balance. Okay, state symbols. What do you know about state symbols? What are the examples? Okay, you have solid, liquid, gas, and aqueous. What's the difference between liquid and aqueous? Very good. Liquid is 100%. Aqueous is mixture. Okay, you have water inside. When you have water inside, it's not 100%, then it is aqueous. Okay, what is spectator ion? Does not involve, okay, in the chemical equation, okay, doesn't involve in the reaction. Then how do you identify spectator ion? It appears on the both sides, okay? So for example, if you have at the both sides of the equation, it appears, then you can cancel off. That is your spectator ion. Okay. And lastly, we learn to balance ionic equations where we cancel off the spectator ions. Okay, the one that appears on both sides. Okay, very good discussion today. Very good revision. All of you are very well prepared. Okay, let's proceed to today's lesson. Okay, so today, wait. All right. So the previous lessons, we were mostly talking about solids. Okay, so solids, we have mass divided by molar mass. Okay, we talk about sodium chloride, the salt. Okay, we talk about how many grams of products are being produced. Okay, we talk mainly about solid. If you still remember matters, everything around us. Okay, we have solid, we have liquid, we have gas. Okay, so we have talked about calculations about solid. So today we will move on to calculations involving liquid, okay, involving solution. Okay, so by starting, okay, concentration, there are two types of concentration. The one that you're more familiar with is concentration regarding the mass. Okay, when you have mass over volume, okay, what do you think is the unit? Gram per decimeter cube. Okay, mass is gram, volume is decimeter cube or gram per liter. Okay, so concentration that maybe you have come across is the one where you use gram divided by liter, gram per liter. Okay, okay, so today we are going to learn concentration for solution. So concentration for solution is we use number of mole divided by volume. What do you think is the unit? Very good. Number of mole is mole, the unit is mole. When I divide by volume, volume most of the time, 99% of the time, we will use decimeter cube. Okay, so this is the standard unit, mole per decimeter cube. So this is the one that we are going to talk about. Okay, so amount of solute. Solute means anything that you try to dissolve. Okay, we call it solute. So the amount of solute that you dissolve in a solvent. Solvent means the water, okay? To make 1 decimeter cube of solution, that is the concentration. Okay, so for your information, 1 decimeter cube is 1,000 centimeter cube. Okay, 1 decimeter cube is also 1 liter. Okay, and 1,000 centimeter cube is also 1,000 milliliter. Okay, so you know 1 liter is 1,000 milliliter. So in the case where you get milliliter or centimeter cube, you will know how to convert it to decimeter cube. Okay, so these are the relations. Okay, when I use 1 mole of a compound, I use 1 mole, I dissolve it to make 1 decimeter cube of a solution. So the concentration that I get is 1 mole per decimeter cube. Okay, so to find concentration, my formula is number of mole divided by volume. Number of mole is in mole and the volume is in decimeter cube, giving me the value concentration in mole per decimeter cube. Okay, all right, let's try to do a very simple exercise. Not asking you to move, okay, but to use your brain a bit. I'm going to post the link here in the meeting. Okay, in Microsoft Teams. Here, okay, before I post the link, okay, so the instruction is you click on the link, you will be prompted to put in your name. Okay, for your name, I want you to put your student ID. Okay, because if I say name, then some of you will put your short name, your long name, or only one single name, and then there's so many people with same name. So it will be very difficult for me to trace, okay, who participated in this activity. Okay, so I want you to put your student ID. FIS2308, blah, blah, blah. Okay, put your student ID. And then, okay, this is a game of making a Milo. Okay, let's say I have Milo powder. What do you call it? Do you call it solute, solution, or solvent? Okay, if I have water, the hot water to make Milo, what do you call it? Okay, so you mix and match to the correct answer. Okay, give you guys 1 minute, okay, to try this. Okay, you guys can access Teams, or do you want me to send to WhatsApp? Anyone wants me to send to WhatsApp? No need, so you guys assess it through Teams, okay? Okay, there's also a QR code. If you can't access the link, you can use this QR code. Okay, just quickly drag and drop, okay? Quickly, you cannot use so much time, so just 1 minute. Okay, so remember, put in your student ID because I will trace, okay, who participate and who did not. Okay, I'm going to close this. All right. Okay, let's see. Only 21 so far. I have like 79 students. There's an S missing. Okay, and then we have the leaderboard. Okay, so FIS 2308408. Who is 408? Okay. 509. 509. Okay. 527. Okay. All right. Okay, I believe I couldn't wait any longer. Okay, so 40 it's enough. Okay, so let's discuss. Okay, so you have the options, hot water. So what do you call your hot water? The water that you use to dissolve. Solvent, okay. And then if you have the Milo powder, what do you call it? Solute, okay. And then the cup, the resulting results after you mix it, solution, okay. So something that can dissolve, what do you call it? Soluble. And if cannot dissolve, you call it insoluble. Okay, so just a simple way for you to learn about terms, okay, rather than just showing you. Okay, so exactly the same. I just transfer the whole slides into something more fun for you guys. Okay, so if I have the liquid in which a solute dissolve, I call it a solvent. Okay, anything that dissolve in the liquid, for example, the salt, I'll call it solute. Okay, mixture that is being formed, I call it solution. Okay, things that can dissolve, for example, the salt, I call it soluble. And for example, sand cannot dissolve, I will call it insoluble. Okay, so these are the terms, okay, to revise for you. What are all these S? Okay. All right, so let's try our first calculation. Okay, calculate what is the concentration in mole per decimeter cube. I have sodium hydroxide, okay. Volume is 250 centimeter cube. And then I have the mass equals to 2 grams. Okay, so concentration, as mentioned just now. Okay, the formula is I use mass over volume. Not mass over molar mass. Mass over molar mass is to calculate number of moles. Okay, so concentration is mass over volume. Sorry, number of mole. Okay, number of mole over volume. Okay, so how do you calculate number of mole? I use mass divided by molar mass. Okay, so the mass that you have is 2 grams. So substitute 2 grams. Okay, molar mass, you will use molar mass of sodium hydroxide. Okay, so I hope by now you know sodium hydroxide, 22.99 plus oxygen plus hydrogen. Okay, so this is number of mole. And then volume, okay. Can I just put 250? Why?
We have the
You have to convert it to decimeter cube. Okay, so 1000 centimeter cube is 1 decimeter cube. So if from centimeter convert to decimeter, divide by 1000. Okay, I combined everything so that it's easy for you to see. Number of mole, mass over molar mass. Okay, volume have to convert to decimeter. So this will be decimeter cube, this will be moles. Okay, what do you get? Exactly. Okay, so that's all, 0.2. Okay, yes, don't forget the unit. Mole per decimeter cube. Okay, written here. Okay, can you try this example and see? Okay, it's the other way around. I want you to calculate the mass. Anhydrous means dehydrated, or in another word, without water. Okay, no water. Okay, anhydrous copper 2 sulfate. Okay, what is the formula of copper 2 sulfate? Cuprum SO4. Okay, because cuprum, copper 2 positive, sulfate SO4 2 minus. Okay, so when you cross charge, copper SO4. Okay, cuprum SO4. Okay, copper 2 sulfate in, I have a volume 55 centimeter cube. And I'm telling you molarity. Molarity is capital M. Okay, molarity is 0.2 mole decimeter cube. Okay, the concentration, okay, in mole per decimeter cube, I can also refer it to molarity. Okay, so if you hear me calling or speaking about molarity, it means I'm talking about the concentration in mole per decimeter cube. Okay, so concentration is 0.2. So concentration is number of mole divided by volume. You get 0.2. Okay, so try to calculate the number of mole. Volume, what is the volume that you use? Okay, because you divide by 1000. Always double check your volume for concentration must be in decimeter cube. So if it is in centimeter cube, please convert to decimeter cube. Okay, so what's the number of mole that you get? 0.011 mole. Okay, and then from number of mole, you want to find the mass. Okay, so number of mole is your mass over molar mass. So if your number of mole, you have 0.011. Okay, so molar mass of copper 2 sulfate. This is the formula. Okay, so copper 63.55. Sulfur 32.07, and then 4 oxygen. All right, so what is the mass that you get? And anyone who have gotten the mass?
59.
1?
59. Oh,
okay, the total, the mass.
56.
1?
0.756.
756. Can anyone help to agree with the answer? Okay, thank you. All right. Okay, please try 15 and 16. Okay, try it first. I'll go around and just have a look. Give you some time to try it. Okay, I did 2 examples with all of you. So I believe question 15 and 16, perhaps you can try. Okay, as I've been saying, please use a periodic table in data booklet. Okay, you have to get used to this data booklet. Okay, cannot depend on the periodic tables that you have. All right, so let's continue. Okay, we can't wait very long. Okay, calculate the concentration. Okay, I have a solution. I have 2 grams in 50 centimeter cube. All right, so concentration, capital M, number of mole divided by volume. Number of mole, mass over molar mass. Sodium hydroxide, okay. I'll allow you to calculate the molar mass of sodium hydroxide. What is that? 0.996. Okay, thank you. Okay, and then the volume, what about the volume? 0.05, okay, because centimeter cube, okay, change to decimeter cube. Okay, so what do you get? Exactly 1.0. Okay, thank you. Mole per decimeter cube. Okay, next, slightly longer. I have a solution of ethanoic acid. The formulas are given to you. I have 12 grams of ethanoic in 250 centimeter cube of solution. So again, number of mole. Okay, this one I allow you to calculate. Divided by volume. So volume is 0.25. Again, change to decimeter cube. So what do you get? 0.8. Okay. Mole per decimeter cube. Okay. So if you notice, okay, I'm progressing, okay, whereby the first week I'm showing exactly A to Z, everything. Okay, so that you can copy. Okay, you want to copy first week, yes, you copy. Okay, but coming into the second week, I'll try to leave some blanks. If you follow, okay, you have to know what is that. Okay, no more copying blindly. Okay, you have to solve the rest. Huh? Okay, question 16. Okay, calculate the number of moles of the solute that is dissolved. Okay, so concentration, even the concentration here is 0.2. Okay, so number of mole divided by volume. So I believe now we can very quickly convert centimeter cube to decimeter cube. Okay, so how many mole is that? 0.8 moles. Okay, so all this, like I mentioned, in the slides, it's like level 2 to 3 or 1 to 2 maybe. Okay, very direct. Okay, next, calcium hydroxide, anyone? Formula, Ca, what is the charge? 2 positive, okay, OH minus. 2 positive because calcium, Ca, it's in group 2, okay, so 2 positive, OH is minus. So you will have CaOH2. Okay, so sometimes you will even be tested on the formula. So you have to know how the formulas are derived. That is why yesterday I spent so much time going through the periodic table with you. Okay, so back to here. Concentration, number of mole divided by volume, 0.05. Okay, so number of mole.
0.0005.
How many zeros are there? 3. 0.0005 moles. Okay, how do you write it in scientific notation? Anyone remember? 5 times 3. Okay, so 1, 2, 3, 4. Okay, so -4. Okay, so next. Okay, Before this, we were doing calculations involving stoichiometry, involving chemical equation. And the equations, okay, we are talking about solid. So today we will do one or maybe two, okay, about liquid. Okay, so it's the same concept. Let us look at this. I have the chemical equation. Okay, and then let's plug in the information. As I mentioned, the questions can be very long, so plug in what you have, okay? I have sodium hydroxide, 25 centimeter cube. So this is sodium hydroxide. Volume is 25 centimeter cube. It's exactly neutralized. It's a neutralization by sulfuric acid. So this is sulfuric acid, H2SO4. Sulfuric acid has the volume 15.1 centimeter cube and the concentration 0.2 mole per decimeter cube. Okay, so this will train you on how to read questions, how to identify, okay, the names of the compound, and how to plug in, okay, which information belongs to who. Okay, next, calculate the concentration. I want to calculate the concentration of sodium hydroxide. Okay, so once I have all the information, let's just look at the stoichiometry, easier. Okay, all right, so this is the question. If I have a question here, that means this information is incomplete, so I cannot try to start from here. So I will attempt this part. I have the molarity, I have the volume. What can I calculate from here? Very quick, okay, yes, very good. Because molarity is number of mole divided by volume. So if I have the molarity, okay, you just substitute 0.2. The volume is 15.10. So what's the number of mole? Three. Yes, very good. Okay, very sharp. Okay, I even forgot. Yes, okay, you should convert centimeter to decimeter. No wonder I get a big answer. So 0.0151. 1, 2, 3. Yes, correct. Okay, so what's the number of mole? Okay, it's very long. Okay, try to put in scientific notation. 3.02 times 10, negative 3 mole. Okay. All right. And then as usual, okay, highlight the two that we have. Okay, so I'm talking about sodium hydroxide and H2SO4. So write down their ratio. Okay, always when you solve chemical equation, this is the standard procedure. I have NaOH to the ratio of H2SO4. According to the equation, 2 to the ratio of 1. According to my calculation, I have H2SO4 3.02 times 10 negative 3 mole. So how many moles of sodium hydroxide are there? Thank you. Times 10 negative 3. Okay. If you notice, it's my way of solving so that I don't get confused. H2SO4 is always below H2SO4. Then I'll put this here. The information that I have, the information that I want. Okay, so that you don't get confused. Okay, so that's the example. I want to calculate concentration. Okay, the question is I need to calculate the concentration. I now have the number of mole. Okay, I have the number of mole of NaOH. 6.04 times 10 negative 3. So concentration, number of mole divided by volume. Number of mole is this. Volume, 0.025. So what's the concentration that we get? 2416. Is it? Yeah. Thank you. Mole, and don't forget the unit. Okay. All right. I notice a lot of you are not writing. Okay, never mind. I'll just assume that I have a lot of smart students here. We'll look at the quiz. Okay, we'll look at the quiz results. Okay, so can you guys try question 17 on your own? It's exactly the same. Of course, different substance. Okay, so here will be the steps by steps. Okay, first, what do you need to calculate and everything? But I summarize all in the whiteboard. Okay. All right, try question 17. I also have the equation. It's actually the same substance. I also have the information. Utilizing what we have discussed in the example. Okay, try question 17 on your own and see. Give you guys a few minutes to start. Okay, if any of you who have gotten the answer, you raise up your hand. I think when I have around 3 to 5 students, then I'll discuss. Chemistry, mathematics, physics, statistics, all the calculation questions you have no choice but to do. Okay, if you don't do, you cannot solve them. And if you know that you are weak, you are behind, okay, it's time for you to put in more effort, okay? Look back at the recording, watch back, okay? 1 student, 2, 3, 4, 5. Okay, let's discuss. All right. In quiz, in exam, Miss May will not be there to guide you. Okay, so you have to learn how to do it. Okay, so let's go back. Okay, the same procedures. Okay, so I have the volume. I have, this is molarity. How do you identify? From the unit. Okay, sodium hydroxide. So this is sodium hydroxide. So let's plug in the value. Volume is 20 centimeter cube. Molarity is 0.4 mole decimeter cube. Exactly neutralized by sulfuric acid. So this is sulfuric acid with a volume of 25.25 centimeter cube. Okay, I want to calculate the concentration of sulfuric acid. Okay, so the first step, again, as the question is here, that means that the information here is not complete. So you cannot attempt from here. Okay, I'm teaching you logic on how to start. Okay, so this one shows a complete, so I can attempt, start it from here. I have concentration, I have volume. Concentration is number of mole over volume. When you see concentration, when you see solution, you go to the formula. Concentration is number of mole over volume. Okay, when you see solid, gram, you go to the formula, mass over molar mass. Okay, so here molarity is 0.4, volume is 0.02. Okay, centimeter change to decimeter. So what's your number of mole, class? So many zero. 8 times -3. Okay, thank you. All right, so again, these are my 2 main characters. Highlight it and then go to my comparison. Okay, so I'm talking about H2SO4 and also NaOH. From the equation, 1 mole to 2 mole. Okay, From the question or the calculation, this is 8 times 10 negative 3. So what is this? 4 times 10 negative 3 mole. Okay. Now I have the number of mole. I proceed to calculate molarity is number of mole over volume, 2525. So what do you get? 0.158. Okay, it's up to you. You want to put 0.16 also can. Okay, don't forget the unit. Okay, it will be very serious. Caution, it will be very serious if you cannot solve this. All right, so this is considered quite simple. Okay, so if you cannot solve this, then it will be very difficult for you to move forward. So please, okay, those who cannot, extra effort. Okay, let's see what is the next slide. Okay, next we move on to deduce stoichiometry by titration. Okay, yesterday we did the deducing also. Deducing means something like proof. Okay, proof that this is that. Okay, let me move this to the whiteboard. I think I did. Okay, it's here. Okay, so the same thing, if I have the information for both my reactants, I find the number of mole, I can have the complete chemical equation or stoichiometry. Okay, let's see what I have. I have this volume, 25 centimeter cube, molarity 0.05 mole decimeter cube of metal hydroxide. So given to you, metal hydroxide is MOH2. Okay, I titrate it against a solution. When I titrate against something, that means I add with something. Okay, and the solution is I have this molarity 0.2 mole decimeter cube, hydrochloric acid. So hydrochloric acid, what's the formula? HCl. And it requires 12.50 hydrochloric acid. So volume is 12.50 centimeter cube. Okay, deduce the stoichiometry. When you deduce the stoichiometry, definitely the information will be complete. Okay, because you need the complete information to find the number of mole. Okay, so, okay, if it is a neutralization reaction, do you remember what will be formed? I have hydroxide, your alkali, plus acid. Metal salt, okay, plus water, very good. So can I just ask you one step further? What do you think is the formula of the metal salt formed? Using what you have learned. Very good, huh? Okay, so how do you know it's MCl2? Okay, so M. Okay, and you have OH. OH is always a OH minus. Okay, if you have a MOH2, what does it mean? Your metal is 2 positive. Okay, and then your titration, okay, the salt that's being formed will actually take metal. Sorry, it's a bit lagging. It will take metal and the chlorine. And then the water that's being formed will be here. Okay, H and OH. Okay, so water will be the H from the acid, OH from the alkali. So the metal hydroxide will be here. Okay, M2 plus, and then you will take over the chlorine. Chlorine is minus. So when you cross charge, you will have MCl2. Okay, all right, so you cannot balance it yet because as mentioned, this is a proving question. So here I have molarity, I have volume. I can then calculate molarity equals to number of mole over volume. Okay, and then this side also I can calculate molarity is number of mole over volume. Okay, deducing, we always want to calculate the number of mole. Okay, so try to calculate what's the number of mole that you get. 0.0? Oh, yes. Okay, thank you. Very good. Yes, thank you very much. Yes, you are correct. Okay, so what's the number of mole here? 1.25. And this one? Oh, times 10 negative times 10 negative 3. Okay. What about your HCl? 2.5 times 10 negative 3. Okay. How do you find the ratio, class? Divide by the smallest. Okay, so the smallest is 1.25 times 10 negative 3. 1.25 times 10 negative 3. So the ratio 1 to 2. Okay, then you can then put 1 to 2. Okay, is it balanced? Yes, I think the water you need to balance 2. Okay, so 2 hydrogen, so 4 hydrogen atom, 2 oxygen, 1 metal, 2 chlorine. Okay, so this is deducing. Deducing, you always find number of mole, find the ratio, put into the reaction, the formula, okay, the chemical reaction. Okay, can you try question 18? Exactly the same again. Okay, so you just utilize what you have learned as an exercise, question 18. Okay, it's also metal hydroxide. Okay, I'll give you guys a 10 minutes break. Okay, I think we are now 9:42. I'll give you guys a break until 9:52. Okay, so throughout the break, you can try this. Then coming back, we can discuss. Okay, do you mind if I just call names, okay, randomly? Okay, Angeline. Okay. Johnny. Okay. Ziqian, Qing Ziqian. Qing Ziqian. Oh, sorry. Connie. Connie Tang. Okay. Eunice Ku. Muti. Okay. Samad Kartanbe Sam. Oh, okay. Yai. Bael. Zhou Xuan. Junxian. Li Junxian. Okay. Lin Yishen. Oh, water. Liu Xiaopei. Gui Shen. Xiao Hong. Pe Qi Huang. Oh, okay. Sean Liu. Oh, Emma Siu. Amy Edith Martina. Oh, okay. Stephanie Chai. Tan Hui Yi. Tan Jiayong. Tai Xuan. Tan Tai Xuan. Wen Yi. Tan Wen Yi. Tan Ying Xuan. Teo Jinming. Jeremy Teo. 跳or 跳跳。Daily Auntie Yilin Wang Yilin Ralph Beck Alicia Elhan Samanov Arabakov Nikolai Avery Simon, okay. Bryson Ling Ning Alice Ng. Oh, okay. Okay. Hui Si Gan Hui Si Tai Min Hui Min, okay. Jody Law Kai Wei Kan Kai Wei He Hua Ru Chi Vasilisa Ying Xuan Zheyang Jing Xuan Li Jingxuan. Okay. Li Joey Yi Xiang Li, okay. Jingxi Lim Jingxi, okay. Yihen Louis Karen sorry. Maximus okay. Nicole Ricky Yap, okay. Serena Hao Xuan Valerie Xuan Ong. Oh, Xuan Ong. Oh, okay. Kai Hen. How to pronounce Kai Hen? He-hen. He-hen. Or K-Y-H-E-N-N. K-hen. Or He-hen lah. He-hen. Oh. Razor. Bin. So, okay. Soher. Get Yi. Yoliven. Yan Xiang. Lana. Pavlov or Arson T. Oh, okay, sorry. Ellie John. Arena. I know the table is very small. Yeah, okay. I also don't really like the setting of this. It's very small. Students very difficult to do writing. And sometimes the table is not very stable also, right? Sometimes it just flip. Okay. I do understand. I don't need to be embarrassed if you drop something. Okay. I can understand that. Okay. All right. 3 more minutes. We will continue. Any of you have managed to figure this out? Just have a look. I hope majority of you. Okay, thank you so much. Okay, so 3 more minutes. We will just continue discussing this. All right, 9:53. Okay, let's continue with the remaining part of the lecture. Okay, so I've written here, okay, simplified the question. I have metal hydroxide. Again, it is an alkaline, okay, alkali, react with acid, HCl. So the same is going to produce MCl2. Why? Because of these two here shows that your metal is a 2 positive, chlorine is a -1. Okay, so when you cross charge, you will get MCl2. Okay, so now that I have the information, okay, it's also to deduce. I ask you to calculate. Okay, this question is even clearer. Number 1, I ask you to calculate the number of mole of metal hydroxide. Okay, so metal hydroxide here, molarity. Okay, I want to calculate number of mole divided by volume. So can I have the answer? Okay, you can't have 0.12 to the power.
0.12, wait, 12 times 10 to the power of -4.
Okay, give me the point first. 0.012.
0.012.
Okay, how do you know to the power and everything? Okay, if you don't remember, I'll teach you. So from the decimal point here, okay, you move until the first number. Okay, 1, 2, 3. Okay, you have to move 3 times. It means that it will be 1.2 -3. You move 3 times, so it will be 3. Okay, so 1.2 times 10 -3. Okay, Samad? All right, next. So this one, again, I have molarity, number of mole divided by volume. So can I have the number of mole?
4 times 10 to the power of -4.
Okay, never mind. Give me the 0 point.
0.0024.
Okay, 0.0024. Again, so how do you know to the power? 1, 2, 3. Okay, move your decimal point until you meet the first number. Then it will be 2.4. You move 3 times, so times 3, times 10 -3. Okay, more. Okay, what's the ratio here? Okay, I think it's quite direct here. Sorry, my whiteboard a bit hang today. Okay, so divided by 1.2 times 10 -3, the smaller number. So 1 to 2. Okay, so 1, 2, again to balance it, 2 H2O. Okay, all right, so let's proceed. Okay, any question? Good, okay. All right, so just now we talked about solution, about liquid, about water. Okay, so now we are moving on to the last matter, the last part, which is gas. Okay, so next week we will also continue with gas. Today we will just touch the surface of gas. Okay, so gases are all around us. The thing is we cannot see gas. Okay, it's not even small. It's just invisible. Okay, we cannot see gas moving. Okay, so the first law that we are going to learn, it's called Avogadro's law. Okay, A. So Avogadro's law says that volume, anyone know what is this symbol? Very good, directly proportional. Okay, volume V is directly proportional to number of mole. When I say directly proportional, it means that if the volume increase, number of mole also increase. That is directly proportional, direct relation. Okay, and then it says that if I have same volume, equal volume of gases, at the same temperature and pressure, it will have same number of molecules. Okay, stop, Miss May. I'm very confused. Okay, when we talk about gases, we talk about a few things. Okay, we talk about volume, we talk about temperature, pressure, and number of mole. Okay, so the first law, we focus on volume and number of mole. If I focus on volume and number of mole, it means that the other two, which is the temperature and pressure, must be constant. Constant means cannot change, must be the same. Okay, then only I can find the relationship between volume and number of mole. So it says that at the same temperature and pressure, okay, if let's say I have 24 decimeter cube of gas A. Okay, I will also have 24 decimeter cube of gas B. Okay, same volume, different gases will have the same number of mole. Let's say this is 1 mole, this will also be 1 mole. Okay, so this is Avogadro's law. Okay, give you around 1 minute to digest this. All right, so gases, we talk about 4 things: volume, pressure, number of mole, and temperature. The first law, Avogadro's law, I want to look at the relationship between volume and number of mole. So temperature and pressure must be the same. Okay, so Avogadro's law says that if at the same temperature and pressure, the same volume of different gases will have the same number of mole. Okay, so this is Avogadro's law. Okay, and then, okay, at standard temperature and pressure, short form STP, okay, standard temperature and pressure, it means that the temperature is 0 degrees Celsius and the pressure is 1 atm. Okay, room temperature and pressure, RTP, it means room temperature, 25 degrees Celsius. Room pressure is assumed to be 1 atm. Okay, don't need to memorize this. Don't need to memorize this. Okay, I've been very good enough, generous enough. Okay, it's also in the data booklet. All right, so what is STP? What is RTP? It's in the data booklet. Okay, so let's move on. Avogadro's law says that volume directly proportional to number of mole. So if my volume increases, okay, by 2 times, my number of mole will also increase by 2 times. If my volume increases by 3 times, my number of mole will also increase by 3 times. Okay, so this is directly proportional. Okay, so as I mentioned just now, at the same temperature and pressure, the same volume of gases, different gases, as long as they have the same volume, they will have the same number of mole. So they will have same number of molecules. For example, at this, okay, 273 Kelvin, 1 atm. May I know what is 273 Kelvin?
0 Celsius.
Very good, 0 degrees Celsius, 1 atm. Can you tell me what condition is this? We just learned just now. Standard temperature pressure. Okay, so all of these at 273 Kelvin, 1 atm. Okay, I have helium, I have oxygen, I have nitrogen. All of them will have 1 mole, 1 mole, 1 mole. Okay, 1 mole of gases. And the volume will also be the same, 22.4 liter. Okay, so this is what it means. Same temperature and pressure, different gases will have same volume, and same volume will have same number of mole. Okay, I would like you to take note, okay? Are the masses the same? Not the same. Okay, remember yesterday I told you guys in chemistry, masses are not significant. What is more significant? Number of mole. Okay, so it shows that all of them have 1 mole. Okay, next, I have different gases. I have nitrogen, I have hydrogen, I have argon, I have methane gas, different gases. Okay, and I tell you, all of these gas has 1 liter. Okay, at this 0 degrees Celsius, 1 atm. Again, what condition is this? STP. Okay, at STP, I'm going to tell you, at STP, okay, it's said that 1 mole of gas will always occupy 22.4 liter. And remember, 22.4 liter means 22.4 decimeter cube. Okay, 1 mole of gas, 22.4 liter. My next question, 1 liter of gases, how many number of mole? Can you guys calculate? Okay, 1 mole is 22.4 liter. So if I have 1 liter, how many mole? I hope you guys know how to do this, mathematics. Okay, 22.4 x equals to 1.0. X equals to? Okay, 0.0446 mole. Okay, so at 1 liter, I will have 0.446 mole. So 0.0446, okay? So 0.045 mole. Okay, regardless of what gas it is, nitrogen, hydrogen, argon, methane, oxygen, helium, whatever, as long as they are gases at the same temperature and pressure, for example, STP, okay, at 1 liter, they will always have the same number of mole, 0.045. And 0.045, how many molecules? How do you calculate this? Times Avogadro's constant, because 1 mole is 6.02 times 10 to the power of 23. So if 0.045, you will have 0.045 multiplied by your Avogadro's constant. You will get this. Okay? All right, let's try to do some calculations. Okay, just now I mentioned at STP, okay, 1 mole will occupy 22.4 liter or 22.4 decimeter cube. Okay, and then we have another condition. What do you call it? RTP, room temperature and pressure. So room temperature and pressure, 1 mole is 24 liter or 24 decimeter cube. Okay, so the first question, calculate the volume that is occupied in 0.04 mole at RTP. Okay, so at RTP, 1 mole is 24 decimeter cube. So now you have 0.4 mole. How much? 9.6. Okay, decimeter cube. Make sure that your unit is correct. Okay, all right, I tried the first one. Can you guys try question 2 and question 19? Okay, I slowly do. Okay, you guys do quickly and try to solve it on your own. Calculate the mass of methane in 120 centimeter cube of methane at RTP. So again, okay, start with what you know. At RTP, I know that 1 mole is 24 decimeter cube. Okay, so how much do you have now? 0.12 decimeter cube. Okay, always make sure that your unit is the same when you want to do equations. Okay, that's the first step. Make sure that your units are the same. Okay, so 0.12 decimeter cube, how many mole? We tried this just now. Cross multiply. Okay, so x equals to 5 times 10 negative 3 mole. Okay, if you have the mole, please take note of the question. The question wants the mass. Okay, so mole, calculate mass. Five times 10 negative 3 multiply molar mass of methane. Again, I'm not giving you the molar mass. You find it yourself. Okay. I really hope, okay, none of you will come to me, okay, after maybe half a semester and tell me, teacher, I don't understand a single thing. Can you repeat? Okay, don't, okay? If you don't understand anything, you have to ask at that instant or after the class or the same week, okay? Don't come to me and then tell me, teacher, repeat everything from the first week until the last week. Okay, that will take like 12 weeks for me to repeat. Okay, so what is the math class?
10 to the power of -2.
Okay, again? Okay, thank you. Okay, if you find it difficult to write 10 to the power of negative what, then you just follow the decimal points. It's okay. Okay, rather than you putting the wrong answer. All right. Okay, question. Oh, I didn't hide the answer. Okay, question 19. Okay, can you guys try question 19? Okay. All right, how many of you managed to calculate for question 19? Just want to see. Just put up your hand proudly. Okay, quite few, huh? Okay, what is the volume occupied by 26 grams of carbon dioxide at STP? Okay, if you have no idea, you can start with, at STP, 1 mole occupies 22.4 decimeter cube. Okay, so now when you have written at least, okay, one relationship, you need to find number of mole for you to get the volume. Okay, the question wants the volume, so you need to first find number of mole. All right, and then it's given you the mass here, 26.4 gram of carbon dioxide. Okay, so first we need to find the number of mole of carbon dioxide, 26.4 divided by okay, what's the number of mole?
0.6.
0.6 mole. Correct? Okay, so 0.6 mole, what is the volume? If 1 mole is 22.6, so 0.6 is it correct? Okay. 13.44, don't forget the unit. Okay, students always tend to forget this. Okay, next, a flask, I have the volume, again, STP, okay? STP means 1 mole is 24 decimeter cube. Okay, now you have this volume. Okay, as I keep on mentioning, make sure they have the same unit. All right, so you convert the unit, it will be 0.12 decimeter cube. Okay, do it step by step. Okay, the question asks for mass, but you cannot jump and directly get the mass. So do it step by step what you can. Okay, at least get 1 or 2 marks here. Okay, so what is the number of mole? 0. Mole is 0.0005. 3, 1, 2, 3. Okay. Okay. So once you have the mole, then you can calculate. Oh, thank you, STP. Thank you very much. Yes. Thanks, huh? Yes, 22.4, not 24. Okay. So 0.12 divided by. So 536, is it? Okay. All right. Okay, so mass will be number of mole times with the molar mass of, which is a 4 point something lah. Okay, so what do you get? 0.005? 214. Okay. Oh, it's not the number of mole. Okay, we are talking about the mass already. Okay. 214 gram. Can somebody agree with this answer? Okay, thank you. Okay. Okay, and then the last part of today's lecture, again, just now we keep on writing deducing. Yesterday for solid, we have deducing. Just now for aqueous, we have deducing. So now, okay, for gas, we also have deducing. Okay, I have propane, okay, reacts exactly with oxygen. So when I want to deduce, must be react exactly. Okay, react with oxygen, and then we'll produce carbon dioxide and of course water. Okay, because anyone knows what process is this? Propane plus oxygen. Combustion. Okay, combustion, burning of fuel. Okay, propane. Okay, your alkane. Methane, ethane, propane, butane, they are all fuel. Okay, when you burn in oxygen, we call this a combustion process. So combustion will produce carbon dioxide and water. Okay, so it's given that, okay, I have 50 centimeter cube of propane, 250 centimeter cube of oxygen, and 150 centimeter cube of carbon dioxide. Okay, these are all gases. Propane is gas, oxygen is gas, carbon dioxide is gas. Why I don't have information for water? Because it's not gas. Yes, very good. Okay, that's why there's no information for water. Why do volume of the gases? Because Avogadro's law says that volume directly proportional to number of mole. If the volume increases by 2 times, the number of mole will increase by 2 times as well. So if I have the volume here, I can then find the mole ratio. Okay, what's the number of mole? What is the ratio that they react, all the gases? Okay, so how do you find the ratio? Just divide by the smallest as usual. Okay, so the smallest is 50. So 50 divided by 50, you get 1. 250 divided by 50, you get 5. 150 divided by 50, you get 3. Okay, all right, so propane, I don't know the formula. Okay, oxygen, what's the formula? Very good. Carbon dioxide. Very good. Water. Okay, the rest you know. Okay, and then I plug in. Remember, deducing, first is you always find the number of mole. When you get the number of mole, and then you plug in the ratio. 1, 5, 3. Okay, and then you slowly solve it. Okay, so let's say here, I have 3 carbon. So what is your 3? Okay, I have 10 oxygen. So what is the ratio in front of H2O? Here I have 6 oxygen already. So how to get 10? 4. Okay, and then so how many hydrogen do you have? 8. Very good. So this is the deducing. Okay, so first, write out the volume of the gases. Second, find their ratio. How many portion react with how many to how many? And then you slowly, okay, build out what is your X and Y. Okay, the last one is this one, question 20. Can you guys try? Okay, give you guys maybe 1 minute to try, then we discuss this. Just try whichever you can until whichever stage. Okay, I've given you the formula, gaseous hydride of phosphorus. So the formula is PHN. Reacts with exactly chlorine to form phosphorus trichloride. What is phosphorus trichloride's formula? P trichloride means 3 chlorine. Tri, okay, 3 chlorine and HCl. Okay. All right. So PHN, phosphorus hydride, chlorine Cl2, phosphorus trichloride, phosphorus with 3 chlorine, and hydrogen gas. Yes. You get it? Very good. Anyone else? Okay, I'm very happy when students are able to get it from like one example or on their own. Okay, and then let's try to plug in the volume. So I have 50 centimeter cube, and then chlorine, 150 centimeter cube, trichloride to form gaseous, and this one, and 150 centimeter cube of hydrogen chloride gas. Okay, okay, and then the ratio, number of mole. 1 to 3 to 3. Thank you. Okay, so let's plug in 1 to 3 to 3. Okay, try to solve it. So what is your N? Okay, because there's only hydrogen at the right-hand side, your product, there's only 3 hydrogens, so definitely you'll be able to get this. Okay, and then is this balanced? 6, 6. Yeah, I think it's balanced. Yeah, okay. All right, so that's all. Okay, so how many moles of chlorine react with 1 mole of gaseous hydride? So I want to know how many chlorine react with 1 mole of gaseous hydride. So 3 chlorine with 1 mole. Okay, deduce the formula of phosphorus hydride. So this one, PH3, the phosphorus hydride. And then write the balance equation. So this is your answer, balance equation. All right. Okay, any question? Good. Okay. All right, so lastly, of course, okay, as usual, some reminders. So I hope, how many of you have not watched the video recording for assignment? You don't even dare to admit. Okay, yes, very good. Okay, just be honest. Okay, so if you haven't, you try to watch it, at least the first 2 videos. Okay, group contract, you will have to submit next week already. So that's why you have to watch it first. Okay, stop packing. Okay, because when you pack, you don't listen, and then you will miss all the information. Okay, so for group contract, I want you guys to print out 1 piece of the group contract, and then you fill up. I mentioned in the video how to fill it up, what can you write, okay? So go according to the video, as specific as possible. If not, you send to me, I will ask you to amend, okay? And then I want the signature of all the members. If possible, you can even poke a needle, get some blood and put it there. Okay, it's an agreement. It's an agreement. Everyone has to agree on. Okay, it will be in class. Okay, the last lecture of next week. I give you until the last lecture, so which is Wednesday next week. You have to submit physical copy. Class, I say already. Stop packing. Okay, so you have to submit physical copy. 1 group, 1 copy. Enough. Okay, proposal also 5 to 6 of you. You will produce 1 proposal and 1 person submit. I don't need everyone to submit, only 1 representative to submit. Okay, I would like to remind, if any of you have started discussing, I want to remind the seriousness. There is a platform for you to submit your proposal before you submit to me. Okay, it's called Eternity. Any of you familiar with this? No, okay, never mind. So in here, they will highlight, okay, this system is going to check how many % that you didn't paraphrase. You know, paraphrase means you completely take from something online and you just copy and paste without changing anything. Okay, so if you would like to do some online research, make sure you type in your own words, okay? Rearrange the sentence structures. Okay, I did teach, okay, in the project proposal how to paraphrase an in-text citation. So try to read it out. Second is AI. Okay, I know it's very popular, gaining popularity, ChatGPT. That system also can detect if you use AI to generate your assignment. Whatever percent detected, let's say that system detects your assignment proposal 50% written by AI, I will deduct 50 marks. Okay, I'm telling you it's very serious. So please, I don't mind about your language. Okay, because this is chemistry. As long as you try your best, okay, I won't deduct a lot of marks, maybe just 1 or 2. Okay, then you'll at least get 8 to 7 marks. It's still okay, it's still good. Okay, don't resolve to AI. It has a very serious consequences. Okay, all right, so that's all for today. Okay, I'll see you guys next week. Okay, thank you, class. FIS 1, we will have tutorial. Okay, so I believe moles and equations you can finish. Okay, so only gas laws you don't need to do. I'll see you in tutorial. Yes?
So today we study
1 minute. Let me just stop the recording.